Hello everyone. So today we are going to be understanding the basics of machine learning algorithms with the help of a real world data set so that we can grasp the concepts together and understand how we can implement the machine learning model by going through each of them, understanding the concepts and implementing them on this data set. So this is the link of the data set that I will be working with. This is from the UC machine learning repository and this is how the data set looks like. It has some description in it, but to summarize what is actually happening in this data set is all about simulating and studying how high energy gamma particles interact with Earth's atmosphere and how these interactions are detected using a special type of telescope, which is the Cherenkov telescope in this case. So the data within this data set is basically simulated and simulated to basically mimic what happens when gamma rays hit the atmosphere. So we will first go through what this dataset is all about. But before going into that, we will simply click on this download button, which is on the website. Simply click on the download button, and it would take you around 2 to 5 minutes to download this dataset. Now, talking about what the dataset is all about, it contains about 19,020 instances or data samples or the data that is to be fed into the machine learning algorithm to make sure that it learns and can provide us with the predictions, right? And then it has 10 different features and one categorical label. So here what do we mean by this is that the features are what is fed into the machine learning model so that it learns the patterns within the data and what the data is all about and makes sense of it. And categorical label is what the machine learning will predict. So for example, in this case it is a binary classification problem. How do we know that? It is because we have only two categories to predict. One is the gamma category and the next one is the hadron category or the background category. This means that we have a binary classification problem with two categorical labels and 10 features, and the data samples or the data points or the instances that we have for this is 19,020. So once the dataset has been downloaded, the next step is to simply go towards the platform where we will be running this data and working with it. So there are different options for you. The first one is that you can run it on your system by using Jupyter Notebook. Another option is that you can use Google Colab so that you can work on cloud and save it, and you can also share your work. Another option is to use Kaggle. Kaggle, I would recommend using it because it provides us, first of all, with a lot of processing power. So, for example, if we have heavy models, we can use GPU. Other than that, we can also import the data set over here, which I really like, and we can use them later on. And all the notebooks that we will be creating will remain in our Kaggle database, and we can later use them and also apply different sorts of algorithms on them. So I am going to be working with Kaggle. So to start off, I'm going to go to home again and show you how I actually went and started working with it. So simply on your home page, you can click on this create button and simply click on this new notebook. Once you have clicked on it, it would take a few seconds, and then you can see a notebook over here, and then you can name it. So for example, I can write demo project over here, demo project 1. Okay. Next step is to see it already has some libraries important into it. You can use this library or you can also import your data and start working with it. So the first step is to import our data. So for that, we can simply click on this upload button, new dataset, and browse files. So the dataset that we just downloaded would be in our downloads folder. In my case, it was in a zipped format. I extracted it, and then it has two files that look something like this. We will only be working with the data file, so I'm going to be clicking on it, and then we can name this dataset whatever we want. So for example, I'm naming it like this, and then we can simply click on the create button. This is giving me this message because I already have this data set downloaded, but but for you, it would not show you this, and it would start uploading the data set. So I can click on continue over here. It will take a few seconds to upload the data set. And once the data set has been uploaded, the upload time depends upon the size of your data set, basically. So once the dataset has been downloaded, as you can see, it has been uploaded successfully. And as you can see, it has this file. And now I can simply copy the path and then use it in my code directly. Okay, so now that we have imported our data, the next step is to start coding. So I have created another file for you, which is much more structured and will help you to grasp the concepts, because I don't want you to waste all your time in typing the code. I just want you to go through the basic concepts and see how the code is actually about and why we have used it, and then you can use it on your own later. So this is the detail of the magic data set that we have just discussed. And now I am going to be highlighting the lines of codes that we are understanding and along the way, so that you do not get confused while working, right? So basically, up until now, you can focus on just three libraries. The first one is the NumPy library, which allows us to work with arrays and NumPy arrays, for example, and we can perform different functions on it. Then we have pandas, which allows us to work in the form of data frames. For example, this is a data frame. It is showing us our entire data in this format like this. And another library that we will be requiring is the matplotlib library, which allows us to visualize our data in the form of histograms or charts or output image or so on. So the first step is to simply read the file. So to read the file, we have a function which is the read CSV function within the pandas library. And simply we are going to just, within this folder, as you can see, we have two files. Now I'm going to copy the path of data and we are simply going to paste it over here as I did earlier. Okay, so just to show you. Now simply if we run this, okay, I think it would give me an error because it was run some time back, and I think it restarted. So yeah. Okay, so first thing first, we are going to run these cells, and you can simply run them by clicking on this play button or pressing shift and enter on your keyboard. So the first step is to import the libraries. The next step is to read the CSV file. So once we click on the play button, we can see that we have run the data set, and now the data set is displayed. But here you can see that we have 10 different features. However, we cannot see those features names over here. So how do we know we have 10 features? If we go back to the dataset description, over here we can see that these are the variable types, these are the features basically, and the role of these is also defined so that you can better understand this. So we want to add these column names to our columns so that it becomes easier for us to understand which is the feature and which is the categorical class label, right? So we are simply going to take a variable which is calls, and then we add all the variables name or the features name which are given over here and add them over here like this. And then to make sure that these column reflect within our data, we will add this names is equals to calls. So as you can see, when we run this, we would be able to see all the features name along with the values of them, and then we also have this class over here like this. So the next step is to as you can see, and as we know that it is easier for us to understand the classes when they are in an alphabetical order, but it is not very easy for the computer to understand, right? So to make the computer understand the categorical labels, we have to convert them into integer forms or the form of 1 and 0. So for this data set, we are assuming that our gamma class should be set to 1 and hadron should be set to 0, reflecting the background. So this line of code exactly does that. So for example, we have taken df class, which is this column, and then we say that convert these class variables or these class values into integers, right? So now that we will run this cell, and next when we run this cell, as you can see that earlier we were seeing G and H over here, now we can see ones, and the classes that have H in them will have 0. So the next step is basically to visualize the data so that we can better understand it. As you can see, it is in numerical form right now. We can understand a few things. For example, the f in this f conc variable or the feature, we can see that the value is 0.53 and then the value is 0.03. There is a drastic difference between them, which can become an issue when we are training a machine learning model. So to better understand the data, we can visualize it, right? So to visualize the data, we will run a for loop which will take each feature, for example, feature 1, feature 2, feature 3, feature 4, up to feature number 10, this one, and then it should not take this class. So to make sure that the for loop understands, we are going to set this. The -1 value here indicates that it will take all the features but it would leave the last feature. So -1 indicates that it is taking all the features and it will create histogram for each of the feature, but it would not create a histogram for the last class. So basically, we are going to plot the histogram, and we have assigned a color of blue to class 1 or gamma, and red to hadron. And then we are classifying, we are basically plotting them based on the probabilities, right? So here you can see we have different histogram based on the different features. Through these histograms, we can understand the data set. So for example, you can see the probability for gamma is much higher compared to that of hadron when we have a length of 0 to 50, right? And then it decreases gradually for hadron, and it drastically decreases for gamma. And one more thing that we can understand from over here is that, for example, for this F alpha, as you can see, for the probability 0.05, gamma is much higher compared to that of hadron. Hadron is much more stable compared to gamma. This basically allows us to have some insights into the data and understand if the data set is imbalanced, if it needs to scale and everything. So it allows us to get better insights into the data. So once we have plotted the data set, the next step is to get it ready to be fed into the machine learning model. So to be fed into the machine learning model, we need to create three different sets: train set, validation set, and test set. So first of all, I think it is better for you to understand what these training, validation, and test set is before we jump in and apply them. So to better understand how train, validation, and test sets work, I have this article over here. I'll share the link of it in the description below. You can go to it and check it out and read it to thoroughly understand what train, validation, and test sets are, and how we can choose them depending upon the machine learning model that we have. So if I scroll down to this diagram, as you can see, we have three different portions: training, validation, and test set. If we only have a training set, and if we train a model on entirely this set, and we do not have any validation and test set, our model will be trained, but the model would not be able to generalize, meaning that the model would be able to make prediction on seen data, but it would not be make a good prediction on unseen data. So to make sure that our model is generalizable and it makes good prediction, we will train our model by using the training data, and then we validate the model. By validating, what we are doing is that we try to tune the parameters of the model to make sure that it improves the performance by using the validation data. And once we think that the model has been trained, the parameters are tuned enough, and then we have some results that are sufficient enough, we can freeze the model. Once the model is frozen, the next step is to test it on the testing data. The testing data is the truly unseen data. To make sure that the model is generalizable, the model is tested on testing data. So this is the simple explanation of how train, validation, and test set look like, and what is their role in the model training and model testing. So okay, coming back to the code, here we have a np.split function. Np.split function is used to split the data set into three different parts. Obviously, you can use a library which is the train and test split to split it, but I am trying to keep it simple over here to make sure that we grasp the concepts. I have created three different variables: train variable, a valid variable, and a test variable, and then use the split function to split the data set. This 0.6 over here indicates that the 60% of the data will be added to the train data set, and then from 60 to 80, which is 20%, will be added to the validation set data set, and from 80 to 100, the remaining 20% will be added to the test data set. This means that we have 60% in the training set, 20% in the validation set, and the remaining 20% in the test set. So to understand what is the distribution of data between these two classes, we are going to be printing it. So for example, we know that class 1 represents gamma and class 0 represents hadron, as we converted it over here as well into integers. So over here, I think this was this line. Okay, so now if we run it, we can see that the data set, that the gamma samples are much more higher compared to the hadron samples, which means that the data set is imbalanced. This is also mentioned in the data set description as well, that the data set is imbalanced. And this becomes an issue when we are training a machine learning model, because it has more gamma sample, it would be more biased towards it. So we have to make sure that our model is not biased. Okay, so to standardize the data set and to make sure that we have a balanced data, we have defined this function over here. I will go through each line of code for you so that we can understand what is happening in the function. So basically we have these two variables x and y. X has the features and y has the categorical labels, and we have defined a data frame in which we are taking all the columns except the last column, because of which we have added a colon over here. This means that all the columns, all the features will be taken except the last category or label. And in the y data frame, we are only taking the last column, which is the category label, which is the gamma and hadron. So the first step is to scale the features. So to scale the features, the purpose is to make sure that we have, for example, that we give equal performance to each feature. So for example, if we go back to this data set, as you can see, as we discussed earlier as well, if we take into account this feature, you can see that we have this value 0.53 over here, and this is 0.03. So the difference between these 2 points is significant. So the model will give more preference to this feature because it has higher value compared to this one, and we do not want that. We want the machine learning model to give equal performance, equal feature importance. So for that, we have used the standard scaler. What it does is it sets the mean to 0 and the standard deviation to 1 for each feature, so that we have a scaled scaled value for each feature, right? And to apply this, we simply use this fit transform function. Once we are done with it, another step that we need to perform is to sample the data set. By oversampling, what we mean is that in gamma samples, we have 7,330 samples, and for hadron, we have 4,082 samples, which is quite less compared to this gamma. So this means that it is imbalanced. So to balance this data set, we are using this random oversampler. There are definitely other samplers that we can use. For example, there is a smooth technique that we will cover in the next few tutorials, and there are also other techniques that we can use, but for now we are only going with the random oversampler for simplicity. And to apply this, we simply use this fit underscore resample function. Once we are done with this, the final step is to stack everything to make sure that we have a data frame which contains both the labels as well as features. So for that, we are horizontally stacking the features and the categorical label, and we have reshaped this because we want to make sure that it becomes horizontal so that we can stack them accordingly. So finally we get these three variables. The first one contains all the features along with their categorical labels. This x contains the features and y contains the categorical label that we want to protect. So this is the function that is going to return this, and the next step is basically to simply run this, and we have to divide our data set into three different variables as we discussed earlier, which is train set, validation set, and the test set. So for training, we are using the scale data set function, and we have set to oversampling to true because we want the number of samples in gamma and hadron to be almost the same so that the data set is balanced. So we are oversampling the class that has less samples, right? So we have set this to true. For validation and test set, we are not setting this to true because the validation set is to improve the performance of the machine learning model, and the test set is to simply test the performance of the machine learning model to make sure that it is generalizable. So we do not need to oversample the samples in these two data sets. We only need to oversample the samples in the trained data set. So finally, if we run this, we can see that we have a total of 19,020 samples, and in the training data set, we have around 14,660 data samples. In validation, we have this much, and in the test set, we have this much. Both of these are equal because this is 20% data and this is 60% of the data. So now that we are done with the basic pre-processing and handling of the data, and we have defined the training, test, and validation set, now our data is ready to be fed into the machine learning model. So in the next video, we are going to go through each machine learning model step by step. We'll understand the concept, and then we can apply it to this project to see how it works and what are the results. So I hope you like this video. I'll see you in the next one.